This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a molecular cloud, I'm a type of nebula. I have a high density and a very low temperature. This combination creates a gas, molecular hydrogen. That's primarily what I'm made of, along with cosmic dust within. When the force of gravity exceeds the outward push of gas, the pressure is so great that I can't help it and start to collapse, which is caused from a shockwave from a near exploding star, or when two molecular clouds collide. Now isn't that bizarre? When the gravity's too strong, I break apart into smaller clouds. Each cloud is a star's beginning, in which I am very proud. Protostars are the name of the clouds that do break free. Let me introduce a protostar that was a part of me. Hello there, I'm the beginning of any kind of star. Let me introduce myself to you, I am a protostar. My core is not hot enough for fusion to occur. To achieve that level of stardom, that process is a chore. The first thing I do when I break free from my molecular cloud, I start to spin until I form this disk around me you see now. As the disk rotates, I produce a strong magnetic field, pulling gas and dust into my center core as I reveal. The infalling gas releases a kinetic energy, creating heat, increasing the temperature in the center of me. At this point, I can transform into a hydrogen burning star, which is when the nuclear fusion starts in a protostar. This is when I cross over to stage 3 called T-Tauri. We play our different roles in the star formation you see. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a T-Tauri star now, also a pre-made sequence star. My job's to clear away the dust and gas and send it really far. My stellar winds create bipolar outflows that decrease my mass, till I'm a main sequence star, my center burning nuclear gas. Now I'm a main sequence star, now just like the sun, you know. For billions of years I will burn throughout my light show. Converting hydrogen to helium is how fusion exists. It wants to blow me apart but has a hard time doing this. Cause of gravity of equal power pushing me in, I'm able to stay burning since the fusion did begin. There are many different kinds of stars throughout the universe. Go learn about them all now that you know how they are birthed. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. Shop our new store merch and get custom birthday videos with your favorite characters. I am VY Canis Majoris, one of the largest stars known in the present universe. I am VY Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. I'm believed to be discovered in 1801, when French astronomer Jerome Lalande locked me in my recordings begun. A red class M hypergiant's what I'm classified as. Now let's focus a bit closer on what makes up this star class. Hypergiant stars show tremendous luminosities and have very high rates of mass loss by stellar winds you see. My distance from the Earth is about 4,000 light years away. 1 light year equals about 5.9 trillion miles, I'd say. I used to be the largest star in the universe you see, until some hypergiants like you Scatai dwarfed me. I am VY Canis Majoris. one of the largest stars known in the present universe. I am VY Canis Majoris. My home's a Milky Way galaxy. This is an interstellar course. If you wanna locate me while looking up in the night sky, you'd have to use the telescope. You can't see me with the naked eye. If you have a telescope, point it to the constellation of Canis Major and look to the left to the Delta Star for a fixation. 990 million kilometers is my radius. Aren't you glad you are paying attention and learning all of this? 5,822 degrees in Fahrenheit is what my temperature is thought to be. I'm hot and extremely bright. And if I replace the sun in your present solar system, I would consume all planets past Jupiter like they were crumbs. I am VY Canis Majoris, one of the largest stars known in the present universe. I am VY Canis Majoris. My home's a Milky Way galaxy. This is an interstellar course. Massive stars like me, we live a very, very short life. I'm reaching the end of my existence, which is part of my strife. I rapidly shed mass because I'm running out of fuel in my course. Scientists think I'll explode into a supernova, but no one knows for sure. I am VY Canis Majoris, one of the largest stars known in the present universe. I am VY Canis Majoris. My home's a Milky Way galaxy. This is an interstellar course. I am VY Canis Majoris, one of the largest stars known in the present universe. I am VY Canis Majoris. My home's a Milky Way galaxy. This is an interstellar course. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I was first cataloged in 1860 by German astronomers at Bonn Observatory. I was named BD-125055 until my second survey. I was found to be slightly more bright. That's when I was named UI Scuti, the 38th variable star of the constellation Scutum am I. I'm the largest known star in the Milky Way galaxy, but because I'm so far from Earth, you need a telescope to see me. I'm 30 times the sun's mass, but I have a radius more than 1,700 times greater than the Earth's sun I span. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I'm 9,500 light years away from your Earth. 1 light year equals about 5.88 trillion miles for what that's worth. I'm known to be one of the most luminous stars, and I am a red supergiant. I hope you like me so far. I'm close to the supermassive black hole Sagittarius A, galactic center, which is the center of our galaxy. I'm so large, if you replaced your sun with me, my photosphere would span past Jupiter's orbit. As you can see, I've begun to fuse helium and continue to fuse hydrogen in the shell around my core based on models of stellar evolution. After fusing heavy elements, my core will begin to produce iron, disrupting the balance of gravity and radiation in its core and resulting in a core collapse supernova, which is expected in stars like me. Look for me in the night sky within your galaxy. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. Shop our new store merch and get custom birthday videos with your favorite characters. We're Alpha Centauri, the closest star system to the solar system your Earth is from. Alpha Centauri is a triple star system. We're 4.37 light years away from your sun. We're Alpha Centauri A and Alpha Centauri B, which forms a pair of stars called binary. Alpha Centauri A officially Rigel Cantorus. Alpha Centauri B officially Toleman I trust. Centauri C officially Proxima Centauri. Here we'll learn about our size and our luminosity. Alpha Centauri A and B are sun-like stars. We're the brightest stars in the constellation Centaurus by far. Alpha Centauri A has 1.1 times the mass and 1.5 times the luminosity of the sun in this class. Alpha Centauri B is smaller and cooler, you should know, at 0.9 times the sun's mass and 0.4 the luminosity shown. We orbit around a common center or around one another, so you'd understand better, with an orbital period of almost 80 years by far. And from a distance we're so close we look like one star. I'm Proxima Centauri, a small and faint red dwarf star. You cannot see me with the naked eye, though I'm the closest star by far. I'm about 4.24 light years from the Earth, and I'm the closest star to the sun for what that is worth. Discovered in 1915 by astronomer Robert Innes, I'm sure, in South Africa at the Union Observatory in Johannesburg. My Latin name Proxima Centauri means when this is defined, the nearest star of Centaurus, that's all that's assigned. We're Alpha Centauri, the closest star system to the solar system your Earth is from. Alpha Centauri is a triple star system. We're 4.37 light years away from your sun. We're Alpha Centauri A and Alpha Centauri B, which forms a pair of stars called binary. Alpha Centauri A officially Rigel Cantorus. Alpha Centauri B officially Toleman I trust. Centauri C officially Proxima Centauri. Here we'll learn about our size and our luminosity. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. William Herschel studied astronomy. In the year of 1781 he discovered me. I have an estimated age of 7 to 9 million years. As for an estimate, that's fine. I've exhausted my core of hydrogen fuel, becoming a supergiant after I expanded and I cooled. I expect to end my life as a type 2 supernova. Here is more, leaving a neutron star or black hole, but no one knows for sure. I'm classified as a blue-white supergiant star, how fun, which is a hot luminous star that's bigger than your sun. I belong to the Orion constellation. Locate me from the celestial equator, from Earth on my run. I am visible throughout the world of this, I am sure. Located in the hunter's leg of Orion, I assure. From the Earth my distance is 860 light years to be clear. 1 light year is the distance light travels in 1 Earth year. 61,500 to 363,000 times as luminous as the sun, my brightness is so grand. But I'll vary slightly in brightness until the day I'm done. I'm thought to be 18 to 24 times more massive than your sun. My radius is a straight line from my center to my circumference, which is more than 70 times that of your sun in reference. My surface temperature is 12,100 kK, meaning Kelvin, a base unit of temperature in the SI, I say. The next time you're out at night, look for Orion in the sky. Look for the hunter's leg. I'm bright to the naked eye. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. Shop our new store merch and get custom birthday videos with your favorite characters. I'm Stevenson 2-18, red supergiant star, the biggest you've ever seen. The new biggest star in the universe am I am much larger than you, I Scutai. My name is Stevenson 2-18 is seen, also known as RSG C2-18. I'm the new largest star found by man, you know, replacing UI Scutai and other largest stars shown. I'm a red supergiant, the largest stars in the universe. In terms of volume, you just learned this in this verse. If Stevenson 2-18 replaced the sun in the solar system, its photosphere would extend beyond the orbit of Saturn. I have an estimated radius of 2,150 times that of the sun. Here's a bit more about me. My volume's about 10 billion times greater than the sun. A little fact you should know. Don't go, I'm not done. That was discovered by an American astronomer, Charles Bruce Stevenson, in 1990, I'm sure. I'm a red supergiant in the constellation of Scutum. Let's see how far I am from your nation. I'm roughly 20,000 light years away from Earth, you see. I shine with 440,000 solar luminosities. I have an estimate of 2,150 solar radii. That's bigger than the star of UI Scutai. My effective temperature is thought to be 3,200 K, meaning Kelvin. I have so much more to say. I'm the new champion of the universe, largest stars by size. Try to find me with your eyes when looking to the night sky. I'm Stevenson 2-18, red supergiant star, the biggest you've ever seen. The new biggest star in the universe am I am much larger than you, I Scutai. I'm Stevenson 2-18, red supergiant star, the biggest you've ever seen. The new biggest star in the universe am I am much larger than you, I Scutai. I'm a star surrounded by a circumstellar disk. My name is HG100546. I'm a star surrounded by a circumstellar disk from the constellation of Musca. Now hear this. My name is HG100546. I'm 316.4 light years from your Earth with exoplanet. I'm a star with a circumstellar disk from the distance of 0.2 AU to a few hundred AU. Now this, I'm found in the constellation of Musca. Hear this, I'm a B-type star with an exoplanet that does orbit. I have an exoplanet that goes by the name you see. It is HD100546b. I'm HD100 10546b. I was discovered at the Very Large Telescope in Chile. Astronomers think I might be a large planet or brown dwarf located in the disk around my star on my orbital course. I'm a gas giant exoplanet, they know this for sure. My mass is 752 Jupiters. One orbit takes 249 years around my star. I'm 53 AU away from my star, that is far. My discovery was announced in 2014. That's all I have to report, that's enough about me. I am back again, it's HD 100-546. Let me tell you a bit more about my disk. My circumstellar disk was observed by the Hubble telescope, which showed spiral patterns. What they mean, no one really knows. My disk is fairly flat with a circular shape, with a wide gap thought to be carved by my exoplanet. How great! When looking at the night sky, try to locate the constellation of Musca, but you have to look late. I'm a star surrounded by a circumstellar disk. My name is HG 100-546. I'm a star surrounded by a circumstellar disk from the constellation of Musca. Now hear this. Shop our new store merch and get custom birthday videos with your favorite characters. I'm known as WHL0137-LS, also known as Arendelle, I do confess. I'm the earliest and most distant known star, replacing the previous farthest known star, Icarus by far. Arendelle comes from Token Silmarillion, the mariner who sails the sky, creating morning again and again. My beloved star shines bright in dark places when all other lights are afar. You'll see my light traces. My discovery was made by the Hubble Space Telescope. Due to gravitational lensing, my observations came full scope. When looking into the constellation of Cetus, the Hubble Space Telescope, when observing, did not miss. My host galaxy WHL0137-ZD1 was nicknamed Sunrise Arc and spiraled as it's fun. If you look from Earth, I'm approximately the distance of 28 billion light years away. I'm a record holder you'll love. I'm almost twice as distant as Icarus, the old record holder, but now I am farthest and I'm much older. My star type is a hot blue star with a mass between 50 and 100 times that of the sun in your system. See, stars with such a high mass as mine do not live very long. Astronomers say I exploded into a supernova you learned in the song. I'm thought to have a surface temperature of at least 20,000 kK, meaning Kelvin I release. Thanks to the James Webb Observatory, we now know I'm either a binary or trinary individual star system that glows. I'm known as WHL0137-LS, also known as Arendelle, I do confess. I'm the earliest and most distant known star, replacing the previous farthest known star, Icarus by far. Neutron stars are the ultra-dense core of a massive star that collapsed. You'll see it's intense when a massive supergiant star just like me runs out of fuel. Let's look from the start so we can see. When the massive hot plasma are being pulled in by gravity, they squeeze the core with force-fusing nuclei in the core you see. Then hydrogen fuses into helium, releasing energy from the core, pushing against the inward gravity. Now this star is stable as long as this balance holds strong, but if the hydrogen runs out, something goes terribly wrong. The star's core turns into iron, the ash of the once nuclear core, because there's no more energy pushing outward, gravity squeezes more. This enormous pressure from gravity crushes is the star's core, fusing electrons with protons into neutrons, I assure. These neutrons get squeezed so tightly by the outward gravity into the iron core, which it deflects while the star implodes, you see. The star explodes into space when bouncing off its iron core, causing a supernova explosion so bright it's not obscure. What is left of this massive supergiant star? It's what this song is about. It's called a neutron star. A neutron star is the strongest gravity outside a black hole, you know. If it were any more dense, it would become a black hole. If you cram 1 to 3 solar masses into a sphere 12 miles across, you'd have the mass of the neutron star inside, it's clear. Neutron stars are the ultra-dense core of a massive star that collapsed. You'll see it's intense. Shop our new store merch and get custom birthday videos with your favorite characters. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. All of the planets in our solar system, they orbit while they follow me. 230 million years is the time I take to fly around the Milky Way galaxy. I don't have a solid surface, I'm made up of gases held together by my own gravity. I'm made of 92.1% hydrogen H2 and 7.8% helium He. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. My core is 25% of my total mass and 27 million degrees. My energy is the reason there is life on Earth. There'll be no charge 'cause I'm totally free. My mass makes up 99.8% of our solar system. Nothing in our system's hot as me. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. Let's fly, 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 let's fly. How does the sun produce its energy? It's a violent and difficult process you will soon see. When you open the sun and look into its core, nuclear fusion is the process in which we will explore. The core of the sun is made up of hydrogen atoms, I'm sure, which are positively charged by protons. Let's learn more. Positively charged protons don't want to fuse to each other unless they're forced by an extreme outside source of pressure. The sun contains 99.8% of all matter in the solar system, which produces massive gravity squeezing the core of the sun. When this gravity created by the extreme mass of the sun presses 4 hydrogen atoms together so they can't run, this pressure creates a fusion of 4 hydrogen atoms, you see, creating a helium atom. This is how it produces energy. There's only room for 2 of the 4 protons within this nucleus. The other protons are carried away by a photon, creating energy in this. This process is what creates nuclear fusion, which is what creates the energy to power the sun. Every second, the sun converts 700 million tons of hydrogen
into 695 million tons of helium over and over again. The remaining 5 million tons of matter are converted into energy, pushing outward from the sun's core to escape the sun's gravity. This pressure counteracts the force of the gravity, stabilizing the sun. Now the star is forced into what's called hydrostatic equilibrium. How does the sun produce its energy? It's a violent and difficult process, you will soon see. Thanks for watching KLT. Please subscribe to this channel, like our videos, and check out the KLT merch store.